Welcome back. This is Tea and Table, my board game design diary podcast. I'm Annie, and today I'll tell you about the latest iteration of my game. So far, I haven't talked in depth about the mechanics and gameplay, but now I feel pretty good about the card play specifically, so this should be a good time to talk about that. So, as I have mentioned a couple of times now, but just to be sure, the game I'm working on is about cooperatively hacking into a network. Your goal as a team is to hack into servers in order to decrypt and exfiltrate data from them. In more practical terms, all players move around the network, which is represented by a map of square tiles. Each square tile represents a domain and has up to 9 interconnected network nodes on it, which represent computers and servers in the network. When you hack into a server, you get a chance to decrypt the data that is on it in order to exfiltrate that data. Now, I've made a bunch of bigger changes in my latest iteration, and I'm trying to solve multiple issues with the previous iteration. Let's focus on 2 of those issues. First of all, the gameplay was not collaborative enough, given it's a cooperative game. And second, I would like to have a fairly smooth and unbureaucratic AI opponent, so the mechanic in the game that works against the players creates pressure and will eventually make you lose the game. So in this episode, I'll explain the card play in my latest iteration and how I hope it'll help with specifically these 2 issues. A major change I've made to the gameplay is to move to a deck building mechanic. Let me explain how that works. Each player has a deck of cards that represent various things in their tool set. Most importantly, they can be commands for players to play or execute. They typically cost CPU, so processing power, to play from your hand, and their effects are free-form text on the card. Some commands are hacks, and they let you hack into a server node in the network. Second, a card may simply represent those CPU resources required to execute commands. Importantly, you can play a resource card on other players' turns to help them execute a command, providing an opportunity to collaborate and interact with other players, and an incentive to pay attention to their turns. Now, you might be doubting whether this really makes for interesting decisions. After all, you can just throw in whatever resource card you have in hand, and the only thing you need to manage is whether another player or you yourself will need the resources later. However, crucially, all cards are double-use cards, meaning that any CPU resource card has a second functionality. For example, a command you could execute on your turn. In my mind, this should make for some interesting decisions even outside your turn. Now, coming back to card actions, besides commands and CPU resources, the third option is for a card to allow you to move around the network. For example, a Move 3 card will allow you to hop up to 3 times between network nodes. In order to move between nodes on different network tiles that don't have direct connections drawn between them, you always move through a special node on each tile called the domain router. I think that is generally a neat solution when map tiles are placed randomly and are not guaranteed to line up in specific ways, and being able to define a specific entry point for a tile is useful to create interesting network patterns on the tiles, since you can control exactly where the player enters the tile. Finally, the fourth option is for a card to represent a decryption key. A decryption key is a simple Tetris shape printed on the card, and those are needed to decrypt data after hacking into a server. The data is represented by a card with a grid of squares, where some of the squares have lock symbols in them. Those are the ones you need to cover up using the Tetris shapes from your cards to successfully decrypt that data card. And collecting this data is the goal of the game. Now, when a player hacks into a server, that player reveals one of the data cards, but then all other players may jump in and help decrypt the data, using cards from their own hands, and if the card cannot be decrypted on the current player's turn, negative stuff happens. Again, I want to encourage collaboration and keep people engaged outside their turn. And since cards are double use, playing a decryption key also means that you discard another type of action, since every card has 2 possible actions, but you can only use one of them when you play a card. So to recap, the cards in your deck can represent a command that costs resources to play. They can represent those resources to spend on commands. They let you move around the network, and they represent decryption keys, which are Tetris shapes used to decrypt data cards. Now, I've left out one last type of card, which I call anomaly cards. They are negative and represent the anomalies you cause in the network by moving around and hacking into servers. The more of them you have in your deck, the more alerts you will raise. This mechanic helps with the second challenge, a simple and unbureaucratic AI opponent. It also helped me eliminate rounds from the game, which I talked about in episode 3, appropriately named Game Flow, or How I Stopped Worrying and Got Rid of Rounds. Now, in some games, this mechanic of negative cards in your deck is also used to clog up your deck and reduce the number of useful cards you can play. For example, in the Undaunted series, the Fog of War cards in your deck represent uncertainty and clutter your hand. Or in Heat, Pedal to the Metal, Heat cards represent engine heat and also clutter your hand so that you cannot go as fast as you'd probably like. Currently, I don't plan to use the anomaly cards in this way. Rather, I plan for them to trigger negative effects immediately upon drawing them from your deck, but then letting players draw more cards from their draw pile up to the allowed hand size. Alright, that's it for this episode, and in one of the next episodes, I'll talk about the remaining gameplay elements, for example, the AI opponent. If you have any feedback or thoughts on this episode, you can find my contacts in the show notes. Also, if you enjoy the podcast, sharing it with other people or leaving a review is super helpful. Until then, talk to you next time.